To explain why an airplane is capable of flying, it is first necessary to define the four main forces acting on it, which are lift, a force that forms a 90-degree angle with the relative airflow; drag, a force that opposes the direction of flight; weight, a force generated by gravity that always points toward the center of the Earth; thrust, a force produced by the airplane's engine, responsible for propelling the aircraft forward. With these forces defined, another essential component for the phenomenon is air. When deflected by the airplane's wings, the air flows around them. On the upper surface of the wing, the air moves faster, while on the lower surface, it moves slower due to the aerodynamic shape of the wing, which forces the air to cover different distances in similar timeframes. The implications of this, especially the pressure difference between the upper and lower parts of the wing, can be better understood using Bernoulli's equation. This equation shows that pressure decreases as airspeed increases, establishing an inverse relationship between the two variables. Applying this to the airflow around the wings, we can conclude that since the airspeed is higher above the wing, the pressure in that region is lower, while the pressure below the wing is higher due to the lower airspeed. As a result, a net upward force is created, lift, which allows the airplane to stay in the air by balancing its weight. Finally, two interesting practical consequences of this are flying against the wind. When flying into the wind, the airplane needs to reach a higher speed relative to the air to maintain lift, which can be risky during takeoffs and landings due to the possibility of stalling, loss of lift at low speeds. Therefore, flying against the wind is recommended in these situations because the wing's relative speed to the wind will be higher, reducing the risk of losing lift. Flying with the wind. During cruise flight, flying with the wind is advantageous because the airplane will have a higher ground speed, which reduces the need for more thrust to maintain speed, resulting in fuel savings.